Relations between the United States and Venezuela have been marked by long-standing political and economic tensions, particularly since the late 1990s. Disagreements over the governance, democratic legitimacy, and control of natural resources have led to the imposition of the extensive economic sanctions by the United States. These sanctions have significantly affected Venezuela's economy and political stability. Because of the interaction involved a sequence of strategic decisions made over time rather than one-time policy choices, the conflict is well suited to analysis using the dynamic game theory. In this study, the US-Venezuela conflict is modeled as a dynamic game with incomplete information. The United States must choose whether to intensify or maintain sanctions without fully observing Venezuela's true political range. Venezuela, on the other hand, has a private information about its regime stability and decides whether to comply with international demands or resist external pressure. This information asymmetry influences the strategic behavior of both players. The key objective of this analysis is to characterize the equilibrium strategies of both sides and to understand how belief about regime change affect policy decision and outcome.
So in this study, we model the US-Venezuela conflict using a dynamic extensive form game. There are two strategy players, the United States and Venezuela. The United States is modeled as the first mover because it has greater economic and political leverage, particularly through sanctions policy. Venezuela moves second, responding after observing the US action. In addition, nature is introduced to represent uncertainty regarding Venezuela's internal policy cohesion, which can be either high or low. This uncertainty is exogenous and not direct controlled by either player. Next is strategies and game structure. The game unfolds over three sequential stages. First, nature determines the level of political cohesion between Venezuela, which can be either high or low. In the second stage, the US chooses between maintaining or intensifying economic sanctions or engaging in negotiation with conditional sanction relief. In the final stage, Venezuela responds to the US decision by either complying with US demand or resisting them. This sequential structure reflects the real-world timing of foreign policy decision and strategy responses. Next is information structure. The game is characterized by imperfect and asymmetric information. Venezuela privately observes its own level of political cohesion, while the US does not directly observe this condition and instead form belief about it. However, all past strategic actions are observable, and the structure of the game, available strategies, and payoff ranking are common knowledge. This setup captures the information asymmetry typically faced by policymakers when making decisions under political uncertainty. So the interaction is represented using an extensive form decision tree, clearly showing the sequence of moves and possible outcomes. Payoff reflects relative political and economic outcomes rather than exact values. Given the presence of uncertainty and asymmetric information, the appropriate solution concept is the perfect Bayesian-Nash equilibrium.
Next, the model evaluates outcome from a national level perspective. Both United States and Venezuela payoff are based on a set of clearly defined evolution dimensions, and the numerical payoff represent ordinal ranking of overall national gains. For the United States, payoff are evaluated along four national level dimensions. First, energy security, which capture the stability, diversification, and resilience of oil supply. Second, geographic and strategic advantage, including military, logistical, and regional positioning. Third, geopolitical influence, defined as the ability to shape regional political outcome and constrain rival powers. Finally, security externalities such as regional stability, transnational crime, and long-term domestic security cost. Together, these dimensions reflect how different political and strategic outcomes translate into U.S. national gains or losses. Similarly, Venezuela payoff is evaluated based on national level outcome rather than the interest of a specific government. This includes national sovereignty, referring to political autonomy and freedom from external coercion. Economic performance measured through oil revenue, trade access, and macroeconomic stability. Also, energy control and security, meaning the ability to manage and benefit from national oil resources. And last is the governance stability and public welfare, which capture political cohesion, institution capacity, and social well-being. Based on the combined performance across these dimensions, outcomes are ranked using ordinal payoff values. Payoff 4 represents the highest overall national gain, and payoff 3 indicates moderate national gain. Payoff 2 reflects limited gains with persistent vulnerabilities, and payoff 1 corresponds to the worst national outcome. This values are ordinal rather than cardinal, and they are used to compare uptime, not a measure exact welfare levels. Since the United States cannot directly observe Venezuela's internal political cohesion, after Maduro's capture, a strategy decision must be based on subjective belief rather than complete information. So, for the probability assumption to examine how U.S. strategy incentive change under different belief, we consider two probability scenarios. The first case represents a conservative belief scenario where internal political cohesion in Venezuela is perceived to be relatively high. In this case, the US assigns a probability of P equals to 0.7 to high cohesion and 0.3 to low cohesion. This belief reflects the assumption that loyalist networks and institutional control persist, opposition coordination remain limited, and the risk of regime transition is perceived to be relatively low. As a result, a higher probability is assigned to outcome where loyalist forces remain in power. The second case represents a more radical belief scenario, where internal cohesion is perceived to be significantly weaker. Here, the US assigned a probability of 0.4 to high cohesion and 0.6 to low cohesion. This belief reflects acceptation of political instability, increased internal fragmentation, elite defection, and intensified external interference or domestic discontent. Under this condition, the likelihood of regime transition increased, making opposition takeover more probable. These probability assignments are not intended to predict the exact political outcome, but to capture possible belief distribution that allow comparison of strategy behavior under different level of perceived regime cohesion.
Okay, to conclude Nash equilibrium, first we open Gambit and then we open extensive game. And then we define player 1 as a United States and player 2 as a Venezuela. We also use chance player to represent the nature. For the first case, we solve the problem for the conservative scenario. So for that, we create the chance node with the label H and L with the probability 0.7 and 0.6, 0.7 and 0.3. H refer to the high and L refer to low. And next, we add the United States move for the both. And then we connect the red with the dotted, and then we change the label to the N and S. So S refer to the fraction and N refer to the negotiation. And then we create the move for the Venezuela for the all of that. So we create again Venezuela inside the move, and then we change the label with the C and R. C refer to complement and R refer to the resistance. So we repeat this step all over. See, and then we insert the payoff for the each of that, which is 2, 2, and 2, and then 2, 3, 3, 3, 1, 4, 4, 1, 4, 1, 4, 2, 3, 1, and then we calculate the Nash, all the Nash equilibria. So the result is running, and then this is the result. This is the output that we get from the first case. With this conservative scenario. And the next, we go to the second case with the radical scenario. So we just change the probability for the high and L. For the high and low, we give 0.4 and 0.6. The payoff remain the same, and then we can compute the all Nash equilibria. So this is the output that we get from the second case. Okay, from the gambit we get the equilibrium interpretation of the dynamic Bayesian game between the United States and Venezuela. The key idea is incomplete information. The United States cannot directly observe Venezuela through political strength. It is strategy based on the belief rather than certainty. This uncertainty strongly shapes the strategy interaction between both countries. When the belief is P equal to 0.7, United States think Venezuela regime is more likely to be politically strong. In this case, Section dominate negotiation because a strong regime is expected to resist external pressure and refuse meaningful concession. Negotiation therefore bring limited benefit, while Section allow the US to maintain the pressure and protect the strategic interests. But when the P equal to 0.4, the United States assigns a higher probability to Venezuela being politically weak. Here, negotiation become more attractive because a weak regime is more sensitive to the economic pressure and may be willing to be comply. However, Section may still appear in the equilibrium because the US is uncertain whether complement reflect to the true weakness of strategy signaled by the strong regime. From the Venezuela side, a strong regime choose to resistance to prepare political legitimacy and control. Is a weak regime and may comply, but often not particularly, because Section is relief is uncertain and not granted. Overall, the gambit equilibria show that the pronounced Section and resistance are rational output under the information asymmetry rather than policy failure.
The results shows that the incomplete information plays a crucial role in sustaining the conflicts. When Venezuela's regime is politically strong, resistance to sanctions emerges as a rational strategy, while weaker regimes are more likely to comply. Anticipating this response, the United States may continue imposing sanctions even when their short-term effectiveness is limited. Therefore, prolonged sanctions and resistance can arise as equilibrium outcomes rather than policy failures. Overall, the study demonstrates that dynamic game theory provides valuable insights into international conflicts involving sequential decision-making and uncertainty.